Hello everyone, you have officially made it to your last code implementation tutorial. I guess I have to preface this with saying that merge sort is quite a bit more difficult to implement than bubble sort and insertion sort. Like, honestly, significantly more difficult than merge sort, or that merge sort is than bubble sort and insertion sort. So just be ready for that. Be ready to learn. Really focus during this tutorial. Just really focus. Okay, so I have my bare bones. I got what I have going on. The main class, the main method. So let me create my integer array, as always. Oops. And I'll add my, random numbers. I like to start with 6, 4, 10, 9, 3, 7, 2, 1. Okay, so we got like an 8-element array there. And just before I forget, I'm just going to add this last line right here, system.out.println. And we're going to go arrays to string. Hopefully you know this by now. Array. And that is going to print out our array. But of course, right now it is not sorted yet. Okay. So let's get started with this big boy right here. So first things first, if you noticed in the visualization tutorial, there's a lot of well, of course, beyond merging, just a lot of shifting of numbers, a lot of swapping. So immediately what we're going to need to do is we're going to need to have a temporary integer array on hand. We're going to want to continuously copy this array here as this array gets sort of merged, split around. We're just going to want to have a temporary variable, so a temporary array to call on, just to have it on hand, just so we have some values. So this is going to equal a new integer, but we're not going to just copy and paste these values. All we need to do is really create a new integer array of the same length as this one. So now we have our temporary array. Now we can get into the meat of our program. So I'm gonna actually, in the past tutorials, everything was built in this main method right here. In this tutorial, I'm going to build it in a separate method called merge sort. So let's build merge sort real quick. So we're going to want to create public static, and it's just going to be a void method because we can just edit this. If we pass it in as an argument, we don't need to return like an integer array or something weird like that. So we're going to public static void merge sort. And so, as I just said, one of our arguments needs to be this array right here. So I'll just call it sort array. We're also going to need to be able to pass in this temporary array. So I'll create that as an argument as well. And then I'm going to also want to have some sort of indication of the index. So we're going to want one for the low index and one for the high index, because we're going to be splitting it in half, remember? So we're going to want to have on hand the low index and the high index so we can split it in half. So we don't want to just have 0 and 0 in array.length, but I'll show you that in a second. So we're going to have int low index and int high index. Okay, so we have those 4. So just to start off, we can pass in array, temporary, and then we have low index, which is just for the first time going to be 0, and the high index is going to be array.length -1. So of course, oops, not 2, 1. This is the lowest index of the array. This is the highest index. We're good to go. Okay. Gets a little bit more difficult here. So to start, we're going to want to divide it in half. So let's create the mid index. So we'll set this equal to the average, or yeah, I guess you could call it the average, because that's what it is, the high index plus the low index. And we're gonna divide that. Oops. Okay, fix that. High index plus low index divided by 2. So this, of course, is going to give us the index in between those two values. And so now this is where it gets weird. So the reason why we had, instead of just passing in 0 and array.length -1, this is going to be a recursive method. So what that means is we're going to kind of divide these even further. Remember, as I kind of the first thing in the visualization, you continuously divided the array down until you had elements that were just, or until you had arrays of just length 1. So we're going to actually call merge sort again. So we're going to call So we're going to pass in sort array and our temporary array back into this method. And then for the low index is still going to be the low index we passed in. But now to cut it in half, the high index for the first half is going to be now become the middle index. Okay, and now we're going to call it again for the second half of this divided array. So the top half now, not sorry array, sort array, temp array. And so now the low index for the top half is going to be the mid index plus 1. And then the high index is going to be high index. So this is kind of how we divide all of our, we continuously divide our array through this recursive method. But the thing with recursion is you need to have a way to be able to break out of the method, or else you're going to be continuously stuck and the program's going to crash. So how are we going to do that? So what I'm going to do is I need to have sort of a testing argument. So this is only going to continuously, I guess, be recursion if the high index is greater than the low index. Because after a certain point, once we get it to where they're a size of 1, you're going to see that actually what's going to happen is the high index is going to equal the low index. The high index is going to reach 0. So the high index has to be at least larger than the low index for this to keep happening, for us to keep dividing. Okay, so that's good. We have this is the dividing part. This is pretty difficult. So if you made it here with me, good job. But all this does is divide. This doesn't actually do any sorting yet. All we've done is the dividing part. So now we have to actually do the sorting. So for that, I'm going to create another method called merge. So what that's going to do is it's going to merge all of these individual arrays that we've split from the big array. So let's create the merge method. We're just going to do another public static void merge. And again, we're going to want to pass in the sort array. We're going to want to have that on hand. We're going to want to have our temporary array on hand just to have that to copy some values. And then we're going to want the low index for simplicity, a mid index, and a high index. We calculated the mid index here, so we're just going to want to be able to pass something like that in. So now what are our parameters? So again, sort array, temp array, low index, mid index, and high index. Okay, and let's finish off this method right here, add our curly braces. Okay, so now we are able to now we're ready, I guess, to tackle our merging. So kind of I think the real tricky part here is understanding what this sort array is and what this temporary array is. I'd say actually don't worry about that too much. Focus more on the sorting and you're going to have a better grasp because it'll all kind of come together at the end. So at least for now, I'll address it at the end, but for now, don't worry about that. Worry more about the sorting. So let's just kind of picture that we have these in this method. We're going to have these two arrays that have been divided. So it's not they're part of the full array, but they're not the full array itself. So we're going to want to have the two lowest index, we're going to want to have the lowest index of both of these arrays. So I'll create I'll go low index 1 and I'll create a low index 2. And the first low index is going to be equal to the low index that we passed in. This is the parameter. And then the second low index is going to be equal to, remember, it's right here, mid index plus 1. Mid index plus 1. So now we have our the low index. And we're also, I'll kind of address this later. What we're going to want to do is we're going to want to copy the sort array into the temporary array. Again, this is part of, it'll all come first full circle at the end, but for now, don't worry about it too much. What we're just going to want to do is we're going to essentially want to continuously update the temporary array with, I guess you could call it our progress of our sorted array. So the source array is going to be the sort array. And the position is just going to start at 0. The destination is the temporary array. And again, the destination is going to be 0. We're going to copy the whole thing. And it's just going to be the length of the sort array, sort array.length. Okay, so at this point, don't worry about it too much. All you want to think about is you just want to think of this as updating the temporary array with our progress on the sort array. Okay, We have that out of, kind of handled. So now we're going to kind of jump into the comparisons. So I'm not going to use for loops because for loops don't make as much sense because it's quite a dynamic algorithm, the way it merges and or splits and then merges back. So I'm going to actually use a while loop here. So I'm going to want to while test, and I'm going to test up until we run out of elements to merge. So let's say, like, for example, we're merging back. Let's scroll down here. Let's say we're merging like a set of 4 with another set of 4. We're going to want to continue merging until at some point the low index of one of these is no, because remember, like, eventually these will drop off and then we'll only have like 3 and 3 and then 2 and 2 and 1 and 2, and then they'll kind of continuously deplete. So we're going to want to continue to compare up until we have the bottom index less than the maximum. So, like, I guess in this case it would be like 4. So we just want to go up until we run out. So let's say we're going to want to continuously compare while the low index, this one, is less than or equal to the mid index. And we need to make sure that the low index is less than or equal to the high index. So again, this is in terms of the sort array itself, which might be a little bit confusing. But again, like, let's just say the low index is 0 and the mid index is 2. So we're just going to want to go until the low index is equal to or less than 2. And then what that means is this would be like 3 and 4. So we're going to want to go up until this is less than or equal to 4. So we're just pretty much keeping it within the bounds. If you can picture the visualization I showed you guys, we're going to go up until we have no more elements left to merge together. So that's what this expression does right here in this while loop. Okay, so now we're going to do the comparisons. So we're going to access the temporary array here because you'll see in a second what we're going to be altering the sort array itself. So we don't want to be accessing a sort array that's currently, I guess you could say, under construction. So we're going to use the freshly copied temporary array. So we're going to compare the bottom index of this one to, can you guess it? The bottom index of the other one. So we're going to do temporary less than temporary. Oops, I didn't mean bottom index, my low index. Sorry about that. Just saying my words. So low index 2. Okay, so this was just sort of a, oops, I got a little problem here. Temp cannot be resolved to a variable because it's temporary. So this is sort of arbitrary. We could have done greater than, but we'll just say we're going to compare the low one to this one. So if the first like merged array, so like the lower one, if this is smaller than the first element of the other array that we're merging in, because remember we're going element by element, we're assuming that these arrays are already sorted, this sort of within these bounds and with this bounds. So with the smaller element, we're going to want to put that one in. So the sort array of at what element? Well, we're going to want to do it at the low index, but it would be this one, but the low index, we're kind of already assigning it. We don't want to mess with it because we're sort of incrementing it continuously. So I'm just going to create a new variable here, and I'm going to set I equal to low index. So this is essentially like our 0 in this case, like our 0th element. So we're going to set the low index, not the low index, excuse me, I. So we're going to set the lowest one equal to, in this case, it would be temp array low index 1. Okay, and then in this case, we're not going to immediately increment I. We're going to increment the low index. Because remember now that this element has already been assigned, we don't want to mess with this low index 1 anymore. We want the next one higher. So we're going to increment low index 1. Okay, so that's good for this part. But now if this doesn't hold true, we're going to need to do the opposite case. So if low index 2 is less than the low index 1 in the temp array, we're instead going to set sort array I equal to temp array low index 2 instead. And then instead of incrementing low index 1, we're going to increment low index 2. Okay, sounds good. And then now what we'll do is we'll increment I. So what the good way to think about it, just to kind of backtrack, these are sort of our 3 like iteration variables, like a variable you'd see in a for loop. This is the current index of the first merged array. this is the lowest element. So, okay, so I guess low index 1 would be like the first one of this, if this is our whole thing. And then this is the first index of this whole. So it would like start at like 3 in this case. And then I is just the low index altogether. So it would be like this one, because we're going to end up merging it into an array of 8. So we're just going to start here. So in this case, like, let's say like 6 is picked. So then the low index 1 was here. So now it would be here. And then I would also be moved up to here. Or if whatever reason, like this was bigger than 6, or again, this is a poor example because it's not currently sorted, but then this would be incremented from here to here, but I would still be incremented from here to here. So hopefully that just puts things in perspective for you. So this is going to increment the whole sort array as a whole. This is sort of the whole, and this is incrementing the halves. A good way to think of it is that way. Okay, so this will go through all the way up until you have one of these halves of these array is completely depleted. So at some point, this is only going to break until you have sorted one of the halves completely. So that means that you're going to have remainders in the other half. So that's what we have to take care of now, is the remainders, the ones that just kind of slide in. So you're going to take the low index of 1. We'll handle in case the first half is the one that still has some remaining. And while the low index is, again, less than or equal to the mid index, what we're going to do is we're going to set sort array I equal to temp array low index. So we're just going to set it equal to the ones that are remaining. And then we're going to increment I and increment the low index. Okay. And then now we're just going to handle the same situation for the second half. So low index 2, while that is less than or equal to high index, we're going to set sort array I equal to temp array low index 2. Again, we're just going to be sliding in here. That's all we're doing, is sliding in here. Plus. Okay, so now we have those all handled. And now that would be the completely sorted portion of those merged arrays, because we'll have slid in the remaining values. So that is our completed algorithm. Again, this one's like 50 lines compared to like the 10 liners. But just kind of going back to, as I said, I promised you guys I'd touch on it at the end. So this array copy, the way it kind of works, and I hope you've kind of picked up on it as I went along, is as I was explaining, like the sort array is continuously built. So it's continuously being constructed and re-merge, and we demerge it, we split it up, and then we're merging it back together slowly. So like for the first case, like we're merging these individual elements back into one. So it would at some point be like 4 and then 6. And so we have to continuously update this temporary array to resort the sort array to kind of account for the fact that this is a continuous process. So that's all this is doing. We're just re-updating it. And again, these indexes aren't 0 and like the array length, because we're handling it in one chunk at a time. That's the thing. It's all relative to where we are. It's not absolute values. It's all relative. And that's sort of the tricky thing with recursion. It's a really hard thing to put into tangible words. It's fairly abstract, but just kind of examine this. And if if my words aren't making sense to you, if you stare at it long enough, I promise it'll make sense. It's the low index of the first merged array, the low index of the second one, and then of the whole. So it's like first half, second half, whole. And then this is just being continuously updated. Okay, let's pray that this works. Let's see. So we have this array. We're going to hit play. And boom, you'll see that this sorted our array using merge sort. Wow, that was a lot of work, wasn't it? A lot of brain work too. So hopefully I didn't trip you up too much. I hope you enjoyed this, because this is very useful. And as you'll see in the next video, the fastest, actually, believe it or not, sorting algorithm that you learned. So I'll see you in the next video, algorithm speed.